Guys, in this video I will be showing you matrix multiplication. So I want to begin with matrix size. We show matrix size as, for example, 3 by 2. The first number represents the row number of a matrix, and the second number represents column number. So let's make an example. 2, 3, 4, 5, 1, 6. Let's find the matrix size of this matrix. So this matrix has 1, 2, 3 rows. So the first entry of this representation is the row number, and this matrix has 3 rows. And this matrix also has 1, 2 columns. So this matrix is a 3 by 2 matrix. Let's make another example. 4, 5, 6, 7, 3, 1, 5, 3. So this matrix has 1, 2 columns. This is the first rows. This is the first row. This is the second row. So 2 rows. And this matrix has 1, 2, 3, and 4. 4 columns. So this matrix is a 2 by 4 matrix. Let's make another example. 2, 2, 7, 3, 4, 3, 1, 9, 8, 4, 6, 5. So let's find the size of this matrix. This matrix has 1, 2, 3, 4 rows, and 1, 2, 3 columns. So this is a 4 by 3 matrix. So when are we able to multiply two matrices? For example, we can multiply 3 by 2 matrix by 2 by 5 matrix. The only rule is that these numbers inside should have the same value. So it means the column number of the first matrix should be equal to row number of the second matrix. So we can also multiply this 3 by 2 matrix with 2 by 6 matrix or 2 by 3 matrix. Only thing is these two numbers inside should be the same. Let's make another example. 5 by 6 matrix. We can multiply this matrix with 6 by 4 matrix, for example. Or because these numbers have the same values. Or 2 by 7 matrix, we multiply it by 7 by 4 matrix. We are able to multiply these matrices because they have the same values inside. So, and what is the size of the final matrix? So what we get when we multiply these two matrices? You can think like these numbers inside disappear and you get 3 by 5 matrix. Here the final matrix size is 3 by 6. Here it is 3 by 3. And here it is 5 by 4. Here 2 by 4. So now let's make an example. Let's multiply 3 to 4, 1 to 6 by, this is a 2 by 3 matrix, so the second matrix should have 3 rows. Let's begin with 2, 2, 4, and let's let it have 2 columns, 4, 5, 5. So this is a 3 by 2 matrix, and the final matrix that we'll get from this multiplication will be 2 by 2 matrix. So this matrix will be 2 by 2 matrix. So it will have 1, 2, 3, 4 entries. And let's find these entries. The first entry is the first row, first column. So the entry in the first row, first column, how we find it? We multiply two vectors. First row vector from first matrix with first column vector from the second matrix. So this is first row, first column. We take first row and first column, and we make scalar multiplication of these two vectors. So 3, 2, 4 multiplied by 2, 2, 4. So scalar multiplication is 3 times 2 plus 2 times 2 plus 4 times 4. What we get is 6 plus 4 plus 16. So this is 26. This is the first entry. The first entry is 26. Now let's find this entry. So this is the first row, second column. So the first row of the first matrix is 3, 2, 4 multiplied by, this was the first row, second column. So we take the second column from the second matrix, and it is 4, 5, 5. Let's multiply it. 3 times 4 is 12 plus 2 times 5 is 10 plus 4 times 5 is 20. So this is 42. So the second entry, the entry is here, 42. Let's find this entry. This is the second row, first column. So second, we take the second row. 1, 2, 6. 1, 2, 6. Second row, first column. Second row, first column is 2, 2, 4. 2, 2, 4. So let's multiply these two vectors. 1 times 2 is 2, plus 2 times 2 is 4, plus 6 times 4 is 24. So it is 30. This entry is 30. And let's find the last entry. This is the second row and second column. So we take the second row, which is 1, 2, 6. Second row, second column, 4, 5, 5. 4, 5, 5. So let's multiply these two. 1 times 4 is 4, plus 2 times 5 is 10, plus 6 times 5 is 30. So this is 44. So this entry is 44. So that's all. I hope you got this. This is actually very simple, and I hope I could tell it in an easy way. So see you in my next videos. Goodbye.